Scientific notation is of the form a times 10 raised to n, where your a is between 1 and 10, meaning your a can be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's the only allowed number for your, or allowed value for your a, okay, from 1 to 9. And n is an integer. N can be positive, n can be negative. Okay, of course, if n is 0, then you will have 10 raised to 0, which is equal to 1. Then you don't have a scientific notation. It should be n greater than 0 and less than 0. All right, here's a review on how to write scientific notation. So here, let's try to write this in scientific notation. Where is our decimal point? Decimal point is actually after the last 0. It's over here. Okay, so we have to move this between 2 and 1. So you have to count how many times we have to move our decimal point so that we will have here. So that's 3, 6, 9, 12, 15, 18, 21, 22, 23. Okay, 23. Right? So that's 23. Right? So now if your original number is more than 1, so you have 2.1 already times 10, and we move our point 23 times. Okay, if your original number, in this case this one, is more than 1, then the exponent here will be positive. Okay, let's have another example. 9687.438 times 10 negative, no, there should be no negative. All right, let's say this is my decimal. Let's try to write this scientific notation. So we have to move our point between 9 and 6. Okay, how many times did we move our point? 1, 2, and 3. Now the sign of your exponent here depends on your original number. Since this one is greater than 1, then it should be positive. Express this in scientific notation. So we need to move our point between 9 and 0. So I have to move this point right here 1, 2, 3, 4, 5, 6, 7, 8 times. Okay? So it will be 9.02 times 10 raised to 8. The exponent, or the sign of the exponent, depends on your original number. Since this one is less than 1, then the exponent should be negative. Okay, another example. 0.00693145 times, no, there's no times. That's my decimal. How do we write this into scientific notation? So I need to move my point here between 6 and 9, right? So let's count 1, 2, and 3. So I have 6.93145 times 10 raised to 3. But since the original number is less than 1, then the exponent should be negative. Are these in scientific notation? The shortcut that we're going to use here is LA, LARS, okay, LARS. If you move your point to the left, okay, depending on how many times you move your decimal point, so that you will have, so that you will satisfy scientific notation. Okay, let's say you move to the left. Okay, the number of times that you move, that's the number that you're going to add to your exponent. You move to the left, you add something to your exponent. If you move to the right, you subtract something from your exponent. Okay, let's try to apply this shortcut right now. So I need my point between 2 and 5. So I'm going to move this twice. So 2.5815 times 10 squared, right? Since I moved to the left, then I have to add. How many times did I move? Twice. So I'm going to add 2 here. So your scientific notation is 2.5815 times 10 raised to 4. So that will be your science. Second example, we need to move the point between where? 5 and 0. So I have to move my point how many times? 1, 2, and 3. You move to the left, okay, 3 times. Okay, that's 3 times. So I will have here 5.01639 times 10 raised to negative 5. Since I move to the left, I'm 3 times. Left 3 times, I'm going to add 3 here. So your scientific notation is 5.01639 times 10 raised to negative 2. That's our scientific notation. Now, in our when we discuss problems later on, I will just write this as 5.02 times 10 raised to negative 2. I'll just round it off. For the next one, third example, I need to move my point between 6 and 9. Okay, so I have to move once to the right. Okay, move to the right once. So you will have 6.95 times 10 raised to 9. Okay, since you move to the right once, then you have to subtract 1. Final answer is 6.95 times 10 raised to 8. So that is equivalent to this expression. Final example, I have to move the point between 5 and 5. So I have to move to the right twice. So it means that I will have 5.59 times 10 raised to 7. I move to the right twice. So I have to subtract 2 here. So 5.59 times 10 raised to 5. So that's your scientific notation. So here's the procedure when you multiply two scientific notations. You multiply the decimal numbers together, multiply the two base 10, and when you multiply the base 10, you have to add exponents. So the general formula will be, so m times 10 raised to x times m times 10 raised to y. Multiply the two decimals, m times m, times. Then 10 raised to x times 10 raised to y. Since we are multiplying the same base, you keep the base, and then add the exponents x plus y. Here's our first example. Let's multiply 3.42 times 10 raised to 5 times 4.67 times 10 raised to 9. The procedure was we have to multiply first our decimals. So 3.42 times 4.67, we will have 15.97. So 15.97. Next, we multiply 10 raised to 5 times 10 raised to 9. And when you multiply, if they have the same base, you keep the base and add the exponents. 5 plus 9 will give you 10 raised to 14. Just combine these two together, 15.97 times 10 raised to 14. Now, this is our preliminary answer, but this is not in scientific notation. Okay? So I have to move my point between 1 and 5. So I have to move my point to the left once. So we move to the left once, we have to add 1 to our 14. So your final answer will be 1.597 times 10 raised to 15. Example number 2. 2.93 times 10 raised to negative 2 times 8.3 times 10 raised to negative 5. First step, multiply your decimals. Should be able to get 24.319. Multiply your base 10. And when you multiply 10 raised to negative 2 times 10 raised to negative 5, you keep the base and add the exponents. Negative 2 plus negative 5 is equal to negative 7. Put these two together, 24.319 times 10 raised to negative 7. But then, we still need to write this in scientific notation. So I have to move my point to the left once. Since we move to the left, we have to add LARS. So add 1 to negative 7. This will become negative 6. So 2.43 times 10 raised to negative 6. All right, next example, we are dividing scientific notation. Divide the decimal numbers, and then for your base 10, so 10 over 10 raised to x divided by 10 raised to y, you keep the base, but subtract the exponents. So this will be our general formula. So first example, 8 times 10 raised to negative 3 divided by 2 times 10 raised to negative 2. Just divide your 8 by 2, which is 4. Very good. And then you divide 10 raised to negative 3 by 10 raised to negative 2. So you have to subtract the exponents because we're dividing. You keep the base, subtract the exponents, negative 3 minus a negative 2. It will give me a negative 1. So you will have 4 times 10 raised to negative 1. Since this is already in scientific notation, we don't need to convert this. This will be your final answer. Example number 2 for division. First, you divide your decimals. 3.45 divided by 1.23. You'll get 2.80. Now we are dividing 10 squared by 10 raised to negative 5. Then we have to keep the base and subtract the exponents. 2 minus a negative 5 will turn into 2 plus 5, which is 7. Combine these two together, 2.8 times 10 raised to 7. Since this is already in scientific notation, this will be your final answer. All right. Next example, oh, by the way, you can use our Casio. We just type it in. It will give us the correct answer. But I will not discuss this one right now. If you want to learn how to use your Casio, just watch our channel and I'll put a link in there. Here's your practice sheet. Okay, let's discuss our first word problem. We have a warehouse. Each crate weighs 1.5 times 10 raised to 2 pounds. If we have 6 times 10 raised to 3 crates, what is their combined weight? In this case, we are going to multiply to find the combined weight. So when you multiply your decimal, multiply your base 10, add the exponents. Just so happen that 1.5 times 6 is 9, and this is already in scientific notation. Okay? If you can just skip to the half-life of U and P, that's actually division. Okay, let's discuss this one.
What is this thing?
All right. So do we need to multiply or divide here? It says here ratio, so we need to divide. Now be careful though. Ratio of the P to the U. So P first, which is this, 8 times 10 raised to 7, divided by the half-life of U, which is 2.5 times 10 raised to 5. Remember, it says ratio of P to the U. So when you divide, you should be able to get this as your final answer.